Good morning, everyone. I, Shabbar Kazmi, one of the mathematics teacher of Usha Martin World School, welcomes you all to the online session of Usha Martin World School. So, in today's class, we are going to discuss the topic, the lesson that is derivation of the condition for the consistency and inconsistency of pair of linear equations in two variables in terms of its coefficients. Obviously, we are going to discuss how we can derive these relations for the consistency of system of equations. We are having two cases. For unique solution, a1 by a2 is not equal to b1 by b2. For infinitely many solutions, we are having the condition that is a1 by a2 equals to b1 by b2 equals to c1 by c2, and these all are a1 b1 c1 a2 b2 c2 are the coefficients of the linear equations. Now, inconsistent system of equations, we are having for no solutions, that is a1 by a2 equals to b1 by b2 is not equal to c1 by c2. The thing is this, that students will remember this, and with the help of this they are going to solve the questions based on these conditions. But today I am going to discuss that how we can get these conditions, how we can exactly derive these things. It means how the things are working exactly, we are going to understand in terms of the graphs, and many more things are there. So we'll start our discussion. So let us start our discussion. Okay, so I would like to start the discussion with the graphical solutions of the equations. As we all know that a linear equations in two variable represents a straight line. It means the graph of a linear equations in two variable will always be a straight line. Now let us suppose that we are having two set of equations, that is a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0. Then in that case, obviously the two equations are going to represent two different lines. Then what are the possibilities for the solutions of the different, it means what are the possibilities for the solutions of these equations, this system of equations. So first of all, let us discuss it with the help of a graph. Okay, so let us start now. So we are talking about the graphical solutions. Let us suppose that there are possibilities with the two lines that they can intersect each other. This is the first possibility. The another possibility that they can be overlapping to each other. They can be overlapping to each other. And the last possibility is that they can be parallel to each other. So these are the three possibilities for the pair of linear equations, like whatever the lines are going to be represented by these two graphs, these two equations. So these are the possibilities. So let us discuss the solutions, the possibility of the solutions in the three cases. Like in this case, when the graphs, when the lines are intersecting each other, then in this case we can see that the there is a case of the unique solution. Like this is the point which is going to, this is the point whose coordinate, that is the x and y, is going to satisfy these two, the equations of these two lines, this one as well as this one, these two lines. Now let us see the another case. So this is the case of the unique solution, this one is the case of the unique solution. And now let us go with the another case, that is if the two lines are overlapping each other. Now when they are overlapping each other, so there are possibility of the many solutions. Like there are infinite number of points whose coordinates, that is the value of x and y, is going to satisfy both the equations. So I hope that my students will easily understand these all things. Okay, now the another thing is that, see, these two lines. So obviously the second case will be the case of for many solutions, like the consistent solution system of equations are there and for many solutions. Now this is the another case where the two lines are parallel to each other. It means none of the points are going to satisfy both the equations, because they both are lying on two different lines. So obviously the one, it means The points on the first line will satisfy the equation of the first line, and the points on the another line will satisfy the equations of the another line. So this is the case of the no solution. It means if the lines are parallel, then we are going to get no solution. So this is the case of unique solution, when the lines intersect each other. Unique solution. And when the lines are parallel, so this is the case of no solution. And this is the case of many solution. We can write it as many solution. Okay, so now moving on, how we can correlate these things with the coefficients. So I'm just moving on and I'm trying to make you understand about this. Now I have to introduce one of the thing which is related to the straight line, that is it's one of the form of the equation of this straight line. So this form we have to study basically in the coordinate geometry, but the students must be aware of this. But and still I am also going to discuss more about that particular thing. So now I'm going to introduce the slope intercept form of a equation of a line, slope intercept form of a line, and with the help of this form of equation only we can correlate its general equation and this slope intercept form, and then we can get the relation slope intercept form. Now this is what, this is simply y is equals to mx plus c, where m is equal to slope and c is equal to y intercept. C is equal to y intercept. Now I'm just going to show one of the graph so that I can make it properly understood about the slope and intercept. Let us suppose that there is a one line which is passing like this. It means cutting the y-axis at this particular point. Let us name this point as P, and let us take its distance from the origin as the distance of this point from the origin as C. So this C is only the y-intercept here, and this line is making an angle of theta with the positive x-axis. Okay, now when we take the tan of this theta, then it is going to give us the slope. So we should not have to discuss more about slope. Simply I'm going to just convert the general equation in the slope intercept form, and easily we can get the relation. So we don't have to bother more about slope, because this the students are going to understand more in the class 11th when we go there. Simply to understand about the slope, that is the tan of the tan of the angle made by the line with the positive x-axis. So this is called only the slope, and we'll represent it with the letter that is m. Okay, now I'm just how we can correlate this slope with the coefficients as a1, b1, a2, b2, c2, like this. So I'm just going to convert first of all convert the equation given in the general form in slope intercept form. Let us take one of the example as ax plus by plus c equal to 0. Now if we try to convert it and try to convert it in the slope intercept form, then we can do it like this: by equals to minus ax minus c. We'll continue with it, and we can write it as, therefore y equals to minus a by b, separating it as minus a by b into x, and again separating this also as, we'll write it as plus, and then write it as c divided by b as this. So now we can just compare this equation with the slope intercept form. So we'll get that actually the slope, if there is an equation in its general form, then we can compare this with the slope intercept form, and we can find out its slope and intercept. So obviously if we compare it, so we are going to get it as slope equals to, like, m equals to minus a divided by b, and capital C, that is representing the intercept, equals to minus c divided by b. Okay, so this is the slope and intercept. Now let us again move back and try to understand with the help of graph. Like here we have discussed about the graph. So we can see here, like when the lines are parallel, so what is being common? When the lines are intersect, what is happening with the slope and intercept? And when the lines are overlapping, what is happening with the slope and intercept? If we understood this, then we can easily get the conditions and easily correlate the slope with the coefficients, because we had already got the slope in terms of the coefficient, that is slope equals to minus a by b, and the intercept is equals to minus c by b. Okay, so let us try to just understand. Let us suppose that if the two lines are intersecting, then what will happen to the, okay, I'm just trying to make it understood in a fresh sheet. Yeah, let us try to understand it over here by taking separately the cases. Like we are taking first of all the two intersecting lines in a Cartesian plane. Okay, if we take a two intersecting line, then what will happen? Let us suppose that one line is going like this and the another line is going like this. So what is happening to them? See, one is cutting the y-axis at this point and the another is cutting the y-axis at this point. Then obviously their slopes are different, their intercepts are different, and we can say about the slope. So this line is making an angle of theta, and this line is which is an acute angle theta, and this line is, let us suppose this one as theta 1 and this one is making as angle theta 2. So obviously the theta is different, so their slope must be different. So if only the slope is different, then obviously we are going to get the condition that the lines must be intersecting each other. So for the lines to be intersecting, what will be the condition? For the lines to be intersecting, its slope is not going to be equal, and obviously its intercept is also not going to be equal, but only with the help of slope only we can just get our condition. Okay, now let us try to understand the another case. Like in this case we can write, this is for unique solution. After this discussion we can derive the relation. Let us first discuss it graphically. So this is the case of unique solution. So where in the unique solution m1 is not equal to m2. So this is the case of the unique solution. Now let us discuss the another thing like for many solutions. Now for many solutions we are having the case that the lines must be parallel to each other. So when the two lines are parallel to each other, let us take these two lines as like this, and these two lines are not parallel to each other, they are overlapping to each other. Now if the lines are overlapping, it means they are going to have the same slope. Their slope is going to be equal because both the lines are making the same angle, that is theta, with the positive x axis, and they are having the same intercept. Both the lines are having the same intercepts. So what we can conclude from this, that for many solution what we are going to get in many solution case, we are going to get the slope, that is m1 is equals to m2, as well as c1, that is intercept, is equal to c2. Now we will work with these conditions only. The slopes are equal, the intercepts are equal. Now let us move and discuss with the third part, that is inconsistent system of equations, that is the case of the no solution. So let us discuss that also. Okay, now see then the case of no solution, let us discuss that also. Okay, so in the case of no solutions, the lines must be parallel to each other. See, the two lines must be parallel to each other. This is the first line and this is the another line. So these two lines are parallel to each other. So if these two lines are parallel to each other, so what does it mean? It means that they are going to have the same slope, because this angle theta, so this angle will also be theta. Both these angles are going to be equal to each other because these two lines are parallel, and this is going to be the x-axis is going to be the transversal. So these two angles are going to be equal with the corresponding angle property. When the two parallel lines are being intersected by a transversal, then their corresponding angles are equal. So these two angles are equal. When their angles are equal, it means their slopes are equal, tan of their particular angles. So their slopes are equal. So in this case, for no solution, we can write no solution. No solution. What we can conclude? We can conclude that their slopes are equal. So m1 is equal to m2, but their intercepts are not equal. See, one is intersecting the y-axis at this point, the another is intersecting the y-axis at this point. So their slopes are not equal. So it means we can, so their intercepts are not equal. So we can write c1 is not equal to c2. I hope that my students must understood these things. So c1 is not equal to c2. Now we have to work with these conditions only. Now let us take the unique solution case first. Where is the unique? Yeah, here is the unique solution case. In unique solution case, we are having their slope not equal to each other. We can get the conditions in terms of their intercept too. Now as we know that slope is equals to minus a by b, so when we convert it in terms of a1 b1 and a2 b2, we'll get the first slope, the slope of the first line, as a1 by b1 minus a1 by b1, and the another slope will be minus a2 by b2. So using this only, we can just get for unique solution the condition. I'm just writing it for the now the conditions. For the first thing, for unique solution, for unique solutions. So for unique solution, the lines must be intersecting. So when they intersect each other, their slopes are not going to be equal. That is, m1 is not equal to m2. So we will place the values for the first equation, that is a1x plus b1y plus c1 equals to 0, and the another equation is a2x plus b2y plus c2 equals to 0, and we had got the value of the slope when we had converted the general form of the equation in the slope intercept form as a by b. So in place of m1 we can write a1 by b1. We are going to ignore minus because minus is going to be cancelled out. So a1 divided by b1 is not equal to a2 divided by b2. So this is the condition, and now we can convert this like this also by doing the cross multiplication. We can just operate it and just convert this like this. Implies that a1 divided by a2 is not equal to b1 divided by b2. So this is the condition for unique solutions. I think this one only we had taken. A1 is a1 by a2, the ratio of the coefficients of x is not equal to the ratio of the coefficients of y. Now we'll move on. So for many solutions we are having m1 equals to m2, that is a1 by b1 equals to a2 by b2. The minus sign is being ignored, and we can again convert it as a1 divided by a2 equals to b1 divided by b2. So this is the condition in terms of the slope. Similarly we can get it done in terms of c1 equals to c2. Okay, so this is going to give us c1 by b1 equals to c2 by b2. Here c1 and c2 are the constant terms, and this c1, this is the bigger one. So these are showing actually from the slope intercept form that the intercept, y intercept. Okay, now c1 by b1 equals to c2 by b2. We'll continue this equation also, and we can get, implies that c1 by c2 equals to b1 by b2. Now if we see a1 by a2 is equals to b1 by b2, as well as c1 by c2 equals to b1 by b2, then we can get it easily done as the final conclusion a1 by a2 equals to b1 by b2 equals to c1 by c2. So this is the case for this is the condition in terms of its coefficients for the many solution. Now there is a last one, that is no solution. Many solutions we have got and no solutions. Whatever things we are having in terms of slope, we can say that their slopes are equal but their intercepts are not equal. So we can just again convert it. For no solution case we can do it like this. For no solution, okay, just a minute. For okay, so for no solution we are going to get, see this, for no solution. So yeah, we are getting that its slope is going to be equal m1 equals to m2. It means a1 divided by b1 equals to a2 divided by b2. Now we will again continue with this equation and we can convert it like a1 divided by a2 equals to b1 divided by b2. Now there is one another condition with the intercept, and that is capital C1 is not equal to capital C2. Now if capital C1 is not equal to capital C2, we can write it as C1 by B1 is not equal to C2 by B2. Again we can convert this like C1 divided by C2 is not equal to B1 divided by B2. So again finally we can conclude that A1 divided by A2 equals to B1 divided by B2 is not equal to C1 divided by C2. So this is the final condition. I hope that it is being very easy to understand. Actually I'm just recapitulating all the things, whatever things I had done. First of all, we should know the slope intercept form of the equation of the line, and now we can convert the general equation of the general form of the linear equations in two variables in the slope intercept form, and then from there only we can just get the slope of the line in terms of the coefficient of x and y and the constant term. So we got the slope also as well as intercept also. Now we know that from a graphical point of view how we can get the unique solution when the lines are intersecting, how we can get the mini solutions when the lines are overlapping, how we can get the no solutions when the lines are parallel. Now using these things in unique solution we can get the slope not equal. Now it means both the slope of both the lines are not going to be equal, even their intercept is not going to be equal. So from that we can convert and just we can get the conditions as a1 by a2 is not equal to b1 by b2. And for the second thing we can see over here, for many solutions we had already written infinitely many solutions, a1 by a2 is equal to a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Okay, and now here also how we have got this with the help of that concept only, that in the many solution case the lines will be overlapping, so its slope is also going to be equal and its intercept is also going to be equal. Now in the case of no solution, we can see here in the case of no solution it is going to be inconsistent system of equation. In case of no solution, its slope is going to be equal because the lines are going to be parallel, so its slope is going to be equal, but its intercept is not going to be equal. So we will get that condition a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. At last, I thank all for watching the video. I hope that all of you will understand easily the concept. If any doubt will be there, then I'd like to address all other doubts in the next class. So for now, thank you everyone, thank you for watching, and thank you for being a very good and very honest listener. Thank you.